Hey, Steve with Trimble, the Building Point teams. Scanning before concrete is poured with Trimble FieldLink and an X series scanner is the only way to accurately and on-site QA/QC the location of all in-slab components as well as anything else. Utilizing the familiar FieldLink software, set up your scanner like a total station to align the scans with the model accurately. Then simply move the scanner around, collecting more data in areas that couldn't be seen before, and register and process as you go. Please see previous videos on those two processes. Once you have all the data that you're happy with, and you can actually do this throughout the project or throughout scanning, you can run the comparison. And here you can see I actually have many scans, actually probably too many collected by this customer, as well as many models as well too. To run this comparison, it's usually good to kind of know how your model control can help expedite this and run that comparison a little bit quicker. So I'm actually going to turn off those other models, as well as turn on a section box, which you're going to see here is actually defined as just this little area on the east side of the building, where I'm going to compare this scan data here, you can see it in elevation mode, to the fire sprinkler DWG. So once I'm happy with what I'm looking at, I can just go into my inspection tab, and then I can actually click on the individual components I want to compare, or turn on layers on and off, or what I did just do, compare it to everything that's there, because it's really not going to be too many model components with just this fire suppression turned on. So it's going to go through and actually colorize the point cloud for the distance away from the nearest model component, and that's going to create a lot of gray because there's not many model components there. I can actually turn that off and then start to zoom in here and look at those different sleeves and see that yes, there are bangets coming up for all those, so they're coming into the right spot, and that's looking pretty nice for me. The other thing I can do is bring this into a tighter tolerance, but I'll actually show you that on some structural stuff here in a second. I am going to want to save this with a particular name. We'll call this thing fire, and then save that, and then take an image of this one too. So moving back to my more map section, I'm going to turn on some of those other model components and run that as well too. So let's go to, we'll call it a sleeve check, which I know over here has been a particular issue. So here are many sleeves in the ground. I'm going to turn some other model components back on. Turn this one back on. If we see visually, you can see kind of how they're in and out of where they probably need to be, but maybe close enough, and how there's no sleeves over here, and this is where this is actually caught by the customer. So going in again, kind of doing this in a smaller area to make it a little bit faster. We're going to run this through and run the comparison, but this was actually ran over the entire pour area. So it's going to color again for the distance away from the model here. So here you can see those sleeves are fairly close, within about 1 inch of design at the farthest, and then these sleeves aren't even essentially modeled at all. So could be a pretty big issue for the duct that's running underneath them. So this was captured as it's due and can be communicated through Connect, or just this section can be exported as a non-gridded RCP or gridded. And then when it's imported into AutoDesk, into Revit or Navisworks or AutoDesk Construction Cloud, it'll pop into the right spot, and the GC or the various different subs can see, hey, we're going to have an issue here, and can we design around that? So that is a sleeve check. If I wanted to, I could actually bring this into a tighter tolerance to see, hey, were those sleeves actually outside of 2 inches of accuracy or layout accuracy? It looks like they're actually okay there as well too. So I can bring that tolerance in, and you can see it's going to change that scale as well too. Take another image, and we will name this again, so I can actually export this out as well too. Now the final check I'm going to do for this data analysis is a column check. So let's turn on just those columns, turn this one off and this one off, and turn the structural back on, and then a column check generally just do vertically, you can see here. So it's kind of brought in now. So for these 30-ish scan, about 2 minutes to scan, actually a little less, you're about an hour for collection, and you can see how quickly this analysis can be done, which is in a few minutes, as you see here. So we'll run that inspection one more time. Again, one thing I haven't been doing, but I usually like to do is turn that model components onto the blue so that I can easily tell. Here you can see where the rebar columns are pretty far off, but they'll be probably bent in when the forms are put up, but where that steel columns are actually spot on to where they're designed and where they're installed. So do this for any XYZ checking. And the other thing you can do, which is also very nice, I forgot to save that, so let's go back real quick, is we'll call this one, take an image, and we'll call it column check. And the final thing I usually like to do is actually compare vertical analysis for stair and elevator cores when I have that data available to me as well. If I go back to this perspective mode where you can actually see those bangets coming in, and here you can actually see where the fire sprinkler is in black, you're going to see I have no stair or steel core quite up, so we're just going to do that column example one more time. So rather than changing this, we're going to create a new section box and just do these columns. And hopefully this will show you what it looks like to do it for a elevator core or a stair core as well too. So bring that in, kind of rotate it around, make sure I get it up a little bit higher and a little bit lower too. And then go into my inspection. And so this should give me a pretty good analysis of vertical lean, which we have quite a few videos on elevator core analysis as well too. The X7 is the only scanner that self-levels to 3 seconds. Really the only one that's good enough. Most of the scanners level to 18, 17 seconds, somewhere along that, which is usually not good enough at all for a good actual elevation analysis. So it really helps out with elevator cores and stair cores. That self-leveling in 3 seconds, which means you have sub-millimeter accuracy at 20 meters or sub-quarter of inch over a couple hundred feet. So your data is really going to be spot on. Helps out in floor analysis as well as picture vertical analysis that you see here. So I'll call this column check. This comparison here looks pretty good, and we'll take an image of that. So you can see for those 30-ish or more scans, probably took around an hour, we'll say a little bit longer, just collection, and then how quick it is to align to a model and do that comparison. Obviously this is probably less than 20,000 square foot, maybe closer to 10, but you can cover a lot of area, especially if you can spread it out and check your entire site very quickly. And then if anything is out of place, you can either move it. In this case, we don't have the authority to move these sleeves, or I can communicate that back with an export of just that area or the entire point cloud as an RCP, and it'll come in a recap file into the right location for all those Autodesk programs, or an E57 if I want to actually send it to SDS2 or Tekla or SketchUp. So thank you, and please reach out to your nearest building point representative for any demos or questions that you have.